Okay. Windy. Chuck. Alan. Stroop. Owens. Van Hart. Okay. Person. 1, 2, 3, 4, 5, 6, 7. Oh, and also. Okay. Okay. Present. Hi. Hello, how are you guys?
Good morning.
Good morning. How are you today?
Good morning.
Good morning, good.
5 minutes late. What was the hold up?
Yeah, the technology issue.
Oh, we said that too.
Trying to log in, and it's as a matter of fact, when I tried, I felt my first attempt was good, but then he said that the microphone wasn't working, so I have to kind of troubleshoot it.
Okay.
Anyway, we're here now. Let's begin. Today last week we stopped. I'm sorry, on Monday we stopped at this. We finished the last question and the first question on the binomial distribution. Now we finished all of them except this new question, these two. When I say all of them, I mean this one. That first question, this very first question, that in 5 tosses, a 3 appeared once at no time, and so on. Now, there's somebody here, as a matter of fact, that has the name as guest user. Guest user. Who is that person? Can you say identify yourself so I can mark you present? Guest user. Okay, no response. All right. There's also somebody who is here. Name is showing as iPhone guest. Who's that?
Candace Young.
Oh, Young. Candace Young.
Yes, I'm not sure why it's not showing up under my name. I'm not sure how to fix it.
Oh, no problem. Yeah, mark it present now. All right, let's begin from next question. It says,
sorry, I couldn't unmute my thing. I've been trying to unmute since we got on. I'm sorry.
Okay,
I just was making sure it was working.
Now it says, this question says, I remember I introduced you to binomial, and like I said, we did the first question on that. Remember the formula is here. Px equals n combination x. This part, you get this part from the calculator. Times p to the power x times q to the power n minus x. And I explain what this, I would say variables, all this n, x, p, q, what it means. P is the probability of success, q is the probability of failure, n is number of trials, and x is the number of success in n trials. So this is the binomial distribution binomial probability formula. And remember that the NPQ stays the same, only the x that varies. Having said that, we can now proceed to this one. This question says, it is claimed, well, 1 minute. So it is claimed that a particular flu shot is effective 70% of the time, in 70% of the cases. If a group of 15 students, 15 adults receive the flu shot, find the probability that exactly 10 will benefit from the shot. Now, let me ask you a question. How many of them will receive the flu shot? How many? From the question, looking at the question. How many adults?
15.
15, right? Yes, so your N is 15. So, and then you say that this flu shot is effective 70% of the time. That's your P right there, 70%, which is equal to, when you change it to decimal, 0.7. And then Q is always 1 minus P, which is 1 minus 7. And that gives you 1 minus 7, that gives you
Wouldn't it be 1 minus 0.07?
yeah, 1 minus 0.7, sorry. And that gives you 0.3, right? Am I right?
9 point. Yes.
Yeah.
It's
0.3.
0.3.
Yeah. So now X, it says find the probability that exactly 10, that means our X is 10. Exactly 10 will benefit. So what you're gonna do here is to plug in these numbers. Whenever you see X, you put 10. Whenever you see N, you put 15. X, you put 10. P, you put 0.7. Q, you put 0.3, and so on. So let's put it into this formula right here. So we have P of 3, sorry, P of 10 will be equal to, you say NCX, that means 15 combination 10. 15 combination 10, yeah, times, so I'm gonna adjust this so that it will look more better. 15 combination 10, okay? And this one, combination 10, times P. Our P is 0.7 raised to the power, say, raised to the power X. Now S is 10, times, again, we have to adjust this, raised to the power 10, times Q. Q is 0.3, 0.3 raised to the power N minus X. Our N is 15 minus S is 10. Again, I'm gonna adjust this. Okay. So 15 combination 10 times 0.7 to the power 10 times 0.3 to the power 15 minus 10. So we're gonna put this on the calculator. Let me write this down on paper, then we can put this on the calculator. 15 combination 10 times 0.7 raised to the power 10 times 0.3 raised to the power 15 minus 10. Yeah. Now let's do it on the calculator. If you remember, to get the function NCX, click on this function key here. So these are NCX right here. See NCR right here. Click on it. Now, remember that what we are doing is 15 combination 10. So you gotta put 15 comma 10 right there. So you have 15 comma 10, close the parentheses. Then you go back to the main calculator right here. Say times 0.7 to the power 10, 0.7, excuse me, 0.7 raised to the power 10, raised to the power 10, times, the other part to put in the calculator is 0.3 raised to the power 15 minus 10. 15 minus 10 is 5, right? Am I right? Hello?
Correct.
Yes.
So we're gonna put 5 there. So 15 minus 10 is 5. So I'm gonna do 0.3 to the power 5. 0.3 to the power 5. 0.3 raised to the power 5, since 15 minus 10 is 5. You give me.
All right, I got 0.206.
Yep, 206. Correct.
All right.
0.20. Let me write it. 0.206. You see it on the. Are you sure? Are you sure you didn't took the one I just wrote on the screen?
You say what?
Are you sure you didn't just write the one I have on the screen?
I'm talking about. I'm doing it with you.
Oh, okay. I'm just saying, Miss Owens.
I'm crying. Don't be talking about my laptop, my computer.
You know, don't trust your
That's from the
computer.
dollar store.
That is it.
It
Was
didn't
it the
come from no dollar
computer?
store.
Was it the computer or the calculator that used to make mistake all the time? That's the computer, right? Miss Owens?
Don't talk about my computer.
All right. Now, another way you can get this in fast is to do it on Excel. I like to, get you get very comfortable with Excel, because it will help. It will save your life a lot. Not only for in this class, but so in some other classes you might be taking in future. So I'm going to show you how you can do this in Excel. But let's finish the next question, then I'll explain in Excel. But let me use the next question to explain how you can do it in Excel, because the next question includes more steps, and so Excel will simplify it for us. Any question on this one?
No.
No.
Okay, good.
No, we good.
Good.
Okay.
Excellent. Excellent. Now let's do this one. So this one we're gonna do in Excel because it will require many steps. It says here, a survey found that 45% of teenage consumers receive their spending money from part-time jobs. If 6 teenagers are selected at random, find the probability that at least, see, it says here, at least 3 of them. At least that is a key here. That means out of the 6, at least 3 means 3 or more. That means 3, 4, 5, 6. Right? Yeah, 3, 4, 5, 6, 5, 6. So here our N is 6 teenagers were selected, and the P, you say that depending on 45% of them, it says okay, 45% of consumers receive their spending money from their part-time jobs. So P is 45%, which when you change it to decimal, you're gonna be 0.45. Now Q will be equal, oh, excuse me. Q will be equals 1 minus P, which will be 1 minus 0.45.
So it's 0.55, right?
Yeah. Oh, I will find out. Trust but verify. Mr. Joe, remember? Trust but verify, right?
Say it one more time, please.
Trust but verify. That's what we say in science. I believe you, but I gotta verify it. You're correct. 0.55.
Verified.
0.55, yeah. 0.55. 0.55. Hold on, let me see. Is there a student who is not here? Oh, Joe. That's you. Joe, you're in, right?
Yes, sir.
I saw you. I saw you.
Oh,
You sent me this remind thing. I'm just seeing it now.
Yeah. I was having trouble at first. I don't know what was the problem, but it let me in after I tried a couple times.
That would be the time I was trying to fix the problem. Now, okay. Now we have 6 teenagers. Now it says at least 3 of them. That means our X, it means 3, 4, 5, 6. Which means that we're gonna find the probability of 3.
I have a question.
Yep.
Why would it go higher than 6, or you just giving an example?
You won't go ahead and see because we have 6 teenagers. Remember, our N is 6. You won't go higher than the N. Does that make sense?
Yes.
Yeah. So now this means that you're gonna use this formula here to find the probability of 3. Then write it down separate. Then you're gonna find the probability of 4. Write it down separate. Find the probability of 5. Write it down separate. Then that's a lot of work. After you finish and then you add all of them, that would be a lot of work, right? So to simplify that, we can use 2 things. Either use the table of probability, or you can use Excel. I recommend Excel for you. So let's do it in Excel. it will simplify the whole thing. Okay. All right, let's do it. I'm gonna take you there. Let me write the numbers, and then we have our n as 6, p as 0.45, q as 0.55, x as 3, 4, 5, 6. If you say at most 3, that means 0, 1, 2, 3. But you say at least, that means 3 or more. Yeah. So let's go and put this in Excel. It will simplify. Somebody's again is trying to come in again. Who is that person? Has this guest thing? Anyway, taking you to Excel. This is Excel right here. I'm gonna put our n here. Our n. I'll make it bigger. It's better now, right? You can see it, right?
Yes.
P equals Q equals. Then for my X, I'm gonna list my X here. Let me list my X's here. Yeah, I can read the X here. X. So I'm gonna do it for all of them, 0 to 6. 0, because n remember n goes from 0 to if you remember when I explained it, let me show you something before I do that. When I introduced this topic, when I defined the probability binomial probability, I said that for s goes from 0 to n. So this one around 0 to 6. So I'm gonna get the probability for all of them. Then I will now pick the one I like to answer the question. 0, 1, 2, 3, 4, 5, 6, right? Now, then I'm gonna get the px for all of them. Px, the probability for each of them. Now, the formula we use, let me formula is that, right? Remember to put the equal sign before you put the formula. The formula is the binomial, Excel formula for binomial probability. I'm gonna put n is 6. Our p is 0.5. Oh, sorry, 0.45. And our q was 0.55. Yeah. So now let's do it. You ready?
Yes.
Hello, you guys are ready?
Yep.
Okay, let's
We're
do it.
ready.
Let's do it. Put the formula in. Actually, I'm gonna put a text box here so that you can see what the formula looks like.
You upload this too, right?
Yeah, I'm gonna upload it.
All right,
This is how the formula goes.
Alright.
Equal, see, equals binom dot this. Binomial, of course, it means binomial. See, I'll come back to that in a minute. Binom dot this. It pops out. So you have numbers. Give me 1 minute. Basically, it pops out. Then you follow what it has there. I want to write it down here so you can see binom dot this. I think I wrote it down in this handouts. Give me 1 minute. Let me see if go all the way to the end. See if I wrote it down somewhere. So it to be. I can just copy it. No, I didn't. Okay. No problem. This is where we are. Yeah, good. So we have binom.txt. That's the formula right there. Then you put the stuff in the parentheses in. So let's do it. Let's do it now. So okay, equals sign first to get it put it in a ready mode. Then type binom dot. Now it pops out here. I have binom.txt right there. Double click. Then see you can see where it has numbers. Okay. Numbers is this, see the X right here. Click on this 0 here. That's the first number there. Comma. Then you can see trials. Number of trials is 6. Type 6 there. Comma. The probability of success, see, is 0.45. Type it there, 0.45. Comma. Then you can see these two. Okay. True for cumulative probability. False for mass function. The one we are using is this one here, mass function. So just type false there. False. We're not using the cumulative. Then close it. So binomial does this. See? Once you press the enter key now to give us the answer, and then you can just copy it down. It will calculate the rest. Okay? You have it right here. Then let's copy it down. Click on this, drag it down. Okay. Now, with this, we have all the probabilities from 0 to 6. We can now answer the question. The question was looking for at least 3, right? Am I right?
Yes.
As it says here.
Yes.
It says here, find the probability that at least 3 of them. So at least 3 of them means from 3 up. That means from 3, from here up. I'm going to highlight it. So that the probability of at least 3 equal, I'm going to make it expand it. Yep. It's a little more big. At least 3 will now become equal to add from there, from the highlighter, add from 3 to 6. That means this plus this plus this plus that. Now, before I do that, I'm gonna take you to the book. Here we have that the probability of, write the formula, probability of, make sure you're seeing this. Yeah, you're seeing it. Probably the P of at least 3 will be equal to the probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. Okay. Now, you see them all here in the calculator. I mean, in the Excel, sorry, I say calculator. In the Excel, I'm just going to write them down, and then we can go and type it in there, and then we'll get the answer. So for 3, here, we have 0. Let me make them all 3 decimal places. Highlight and make them, okay. So let me, from 3, you can see 0.303, 0.303 plus 0.186 plus 0.061 plus 0.008, which is, so if we add them all, you can click then this plus this plus this plus that. Once you press the enter key to give you an answer right away. 0.558. 0.558. So it saves us the whole time of calculating this one separate, calculate this one separate, and that takes a lot of time. And then we can go here and type the answers in. To get, for 3, I got 0.303 plus 0.186 plus 0.061 plus 0.008. And that gives us the answer of 0.558. Questions on this?
No.
It's good. You like the Excel, right?
Yeah, it's better.
Yes, sir. It's way easier.
Yeah, it's make it very. It's gonna save you a lot of headache. Yeah.
Man, why you ain't been showing us this way, man?
Huh?
Why you ain't been showing us this way, man? We were struggling with the homework, man. This took like 2 seconds.
Homework is still have till Sunday to be due anyway, right?
Yeah, I think I had my weekend free by now.
Well, you can still have it free. It's only Wednesday anyway.
So the classwork we can do in Excel, or you just, or you
In the classwork, if you use Excel to do it, that means you're gonna upload the Excel file.
Okay.
If you do it on paper with the formula, you gotta take a picture and upload.
Okay. All
Yeah.
right.
Yeah. Now let us round up binomial by doing the mean, variance, and standard deviation of a binomial distribution. The formula for the mean here is n times p. The variance is n times p times q. Then, as always, the standard deviation is the square root of the variance. So let us look at this. So it's a find the mean, variance, and standard deviation of the values of for each value of n. Now, let's just do this one. So excuse me. Let us do this topic is easy. Let's just do this one. Use it to illustrate it for you. The mean here for part A, the mean is the formula is actually here. So this is the mean, and I copy it from here. N times P. Here our N is 100. N equals 100. Okay. P equals 0.75. Then Q equals 1 minus P, which means 1 minus 0.75, and that gives us 0.25. So with that, we can find the mean, variance, and standard deviation for this for part A. So let's find the mean first. The mean is n times P, which means n is 100. Okay, times P is 0.75. And that gives us 75 as the mean. See why I say it's easy. Well, and let me move it down to the next page so we have enough room. So, and then the variance is formula is right here. I'm gonna copy it and paste it here. Oh, right here. So variance equals say n times p times q. That means 100, okay, times 0.75 times 0.25. That gives us the variance right there. So let me write it down, then we can calculate. It's 100 times 0.75 times 0.25. So I'll take you to the calculator so you can find this. So you have 100 times 0.75 times 0.25. 18.75. 18.75. So 18.75. Then standard deviation, that's the one that is just the square root of variance right here. Copy it. So that means it is the square root of this answer here. This one here. So I can't get this character on this. Yeah. So I'm gonna take you to where we can get this character for the radical sign character. To be on the other workbook. So I'm gonna take you there and put the equation there. Square root of that here. That's our standard deviation. Square root of standard deviation. Deviation is delta. That will be square root of variance which is the square root of here 18.75. So we can get it from the calculator, 18.75 square root of square root is right here, 18.75 is 4.33. 4.33. Am I right? Yeah, 4.33.
Yes, sir.
Yeah, 4.33.
Yes.
4.33. So this I'm gonna copy unbold it, copy this, and then paste it right there. For the back for the standard deviation. See? So that's how you do it. You can try B and C as a practice. Let's do the application. That will be the conclusion of this topic. And then I'll introduce you to binomial, to normal distribution. Before I do that, any question on this one? Okay, good. Good.
No.
Now let's look at the application. The application says the statistical bulletin published by Metropolitan Life Insurance Company reported that 2% of all American bets results in twins. If a random sample of 8,000 bets is taken, find the mean, variance, and standard deviation. Well, how many bets we are taking? How many bets?
It was 2. Is it 2%?
No.
What did you say?
How many bets?
2,000.
8,000. Yes, exactly. 8,000.
Man, looking at something.
8,000 bets. That's our end right there. Now, the person that said 2%, 2% is the P. P is 2%, which is 0.02. And our Q is always 1 minus P, which is 1 minus 0.02. Any Einstein here to give us the answer for this one? 1 minus 0.02. What do you get for that? Where are the Einsteins
0.98.
here? Huh?
0.98.
Yep, 0.98. 0.98. Then we are ready. The mean, formula for the mean is N times P. So mean here is equals N times P, which is 8,000 times 0.02. So we got 8,000. 8,000 times 0.02, which is 160. 160 bets result to 20. 160 bets result to 20. Variance equals N times P times Q, which means 8,000 times 0.02 times 0.98. So we're gonna go to calculator. 8,000. We already have 8,000 times 0.02 to them times 0.98. 156.8. 156.8. Then standard deviation, we're gonna use the formula for it. We're gonna get the character from the other workbook and then put it in here. So we're gonna find the square root of 156.8. So I'm gonna take it there. Standard deviation, square root of variance, which is square root of 156.8, which I'm gonna look for it here. Okay, square root of 156.8.
12.5.
Huh?
I said 12.5.
Yes, 12.5, correct. 12.5. 12.5. So we got the answer the question 12.5. 12.5. And that's the solution. Any question on this?
No,
I
no
guess.
questions.
Huh?
I don't have any questions for this one.
Oh, good. So let's conclude our binomial distribution. I guess you guys want me to save this and upload it for you, right?
You already
Yes,
know
please.
that.
Huh?
You already know that.
Yes,
Yes.
please upload
No,
it.
no, I didn't know. They say in America you have to ask first, right? You
I
ask
think you've
first.
already established a
Yes,
routine
sir.
with us that you know you want it.
So from this point further, sir, you have to not ask anymore. We want you
Okay.
to upload.
Yeah. Now that you said it, so then, but you have to before you say that, I have to ask. You know what I mean. So now let me introduce you then to the new chapter, which is normal distribution. I'm gonna open it here. Normal distribution. Okay, let's see. Normal distribution. Where is it? Yep, got it. Normal distribution. You all can see my screen now, right?
Yes.
Yes.
So normal distribution are many variables like height of people, human beings, men, women. There's, when you're an adult, there's a certain height we expect an adult to be. 10-year-old kid, just, I mean, well, kids these days, you can't even know by their age. I mean, how tall they are. Because I saw some kids that are 15 years, but they look bigger than me, But for an adult, like somebody who's from 18 and up, there's a certain height we expect them to be, They don't have to be giant, but somebody have to be that height as an adult. Or then things like cholesterol level. I mean, when they attain that height, we say that it's a normal height for adults. Temperature, that's normal temperature, Like to this one, what we have since this week is not the normal temperature. I mean, summer is hot, yes, but sometimes
So,
it's too
question.
high, right?
I got a question.
Yeah.
So wouldn't they be dependent upon each other? Like, let's say if somebody was like 8 feet, wouldn't their temperature be different because their body is overall higher and the cholesterol level? Wouldn't they be
I understand
dependent?
what you mean by that. But we have in our individual tolerance for temperature, but there's one that you see on the news. That is higher, very high for everybody. Like what you have been seeing on the news, 90 and 100 is high for everybody. Am I right, Mr. Joe?
Sir, yes.
Yes, sir.
But 90, 100 is 100 degrees Fahrenheit. It's high for everybody. But 83 to 85, that one is normal for summer. Everybody knows it's hot already. Some will see that it's too hot. Some will say it's too hot. But when it is hundreds, right? That is not normal for every. Am I right or wrong? Come on, guys, you gotta speak out.
Yes, sir.
Mm.
Yeah, I keep talking, but I keep forgetting I gotta press this button
Yes.
before I talk.
Yeah, it takes a while for me to try to press the
Oh.
unmute button.
Exactly.
Okay. So
We
I'm
here,
here. I'm just at a
Professor.
doctor's appointment. Yeah, we here.
We here.
okay.
We
Now
all
let me.
here.
How about cholesterol level? There's one that is the range that's considered normal.
That is correct.
Yeah, if it's below that range, it's not normal. If it's above that range, not normal.
Right. That's when they want to put you on medication.
Yeah, they always want to put you on medication one way or the other. I don't know.
Trips.
Yeah, a little
That's
thing.
what this country made of.
But
It's the business
but they say
they
that because of that medication and maybe improvement in medical science, yeah, you see, if people live very, except that person, if that person wasn't cut down by a bullet or by a crazy drunk driver, you guys look, your life expectancy is higher compared to some, developing countries because of the improvement in medical science. But medication, there's one student, I remember that was years ago, like when I started at, I started at BCCC as a math tutor. One of my students I was tutoring, she was like, and she said that she has test anxiety, right? And I told her, okay, if you have test anxiety, what you're gonna do is to practice more so that you build your confidence. He said no, that she take medication for that. I said, medication for test anxiety? Want to medical, Miss Owens, in that case, that kind of thing, that side, you are right. Yeah, they want to put you on medication somehow. I can't believe it. I said, why are you taking the medication for test anxiety? All you gotta do is just to practice this over and over and over to build the confidence,
Exactly.
Huh? What's that? I can't hear you very well.
I said that they got medicine for everything.
Some people like it that way. I don't. I mean, if let's say that if my blood pressure is not good and I've tried to handle it through exercise and diet. If it doesn't work and they say, okay, we're gonna place you on medication. I mean, and that's understandable. But if you give somebody medication for test anxiety, I even up to now I can't. It's hard for me to understand it. But I don't see. But some people does that. Anyway, I think you get the point. Now, this distribution I mentioned, cholesterol levels, blood sugar levels, height of adult people, temperature, and even a salary of teachers. That's what is considered normal salary I know each county have different ranges. But if you see a teacher, normal salary, especially a teacher, public school teacher, highest 55 to 80 in many places. Now, if you see a high school teacher that was being paid $200,000 a year, that's not normal. Am I right or wrong?
We don't know.
Oh, yes, we know. Yes, we know. I mean, the person might say, okay, you know what I mean. Come on.
We don't though. German.
Anyway, this kind of variable, we say that they are normal distribution or they are bell-shaped distribution or that they are Gaussian distribution. Give me 1 minute. Let me check something. And I think I opened so many things here and that it's blocking. Okay, good. Excellent. So now we have it here. So considered Gaussian distribution because the name of the mathematician that derived it, developed it. No, I won't say developed, derived it. As we are talking now, in our life, a lot of things are going on around us. But somebody might notice this particular thing and then develop it. That's what he did. You notice that so many things are variable follow this normal distribution, and then he built on it.
That's why you can't tell me none of this stuff ain't made up. All this stuff just be made up stuff that
they're not made up. They exist, but somebody observed it and then built on it.
and made
It becomes a field of study. You know what I mean?
I guess.
You said it was a study, right?
Huh?
You said it was a study. So what they did is just add to whatever was already there.
Yeah, it's a natural phenomenon going on. Then somebody noticed it and then built on it and develop a model around it that we can use to make decision about so many things. And that we call it a Gaussian distribution or normal distribution. So that means that the normal distribution is a continuous this is the simplest definition of it. A continuous symmetric bell-shaped distribution of a variable. We can use it to describe so many variables because of the fact that they deviation from the normal is not, is usually very small. Look at how what they call it bear shape. This is how it looks. Call it the bear curve. Well, I didn't remove so many things here. Okay. So you can look at this. If you look at this bear curve, you will see that it has the center, see the center right here, this line in the middle, and it curves, goes like, it's shaped like a bear. This side is 0.5, this side is 0.5, so that the total area is 0.5 plus 0.5 is 1 or 100%. So more examples, see, there's some variable that follow this distribution. I already mentioned some, but look at the examples I gave here. The normal range of systolic blood pressure is 110 to 140 millimeter mercury. Above that, it's not normal. Below that, it is not normal. Normal interval for the person's triglycerides. I think this is one they call bad cholesterol, triglyceride, right? I think this is the one they call that, the bad one, bad cholesterol right there. So the normal range is 30 to 200 milligram per deciliter. If it's above that, it's not normal. It's below that, it's normal, not normal. So the average birth weight for human babies is approximately 6 to 9 pounds. Above that, not normal. Below that, not normal. So this leads us to the properties of a normal distribution. We can now discuss the properties of normal distribution. Now, the normal distribution curve is bear-shaped, as you can see from here, shaped like a bear. Okay? Right. Second one is that the mean, median, and mode are equal, and they are located at the center of the distribution. That's right there. Center of the distribution. Mean, median, mode, they are on the center. Okay. Now, the curve is continuous. Sorry. A normal distribution curve is unimodal. You have only one mode, which you can see from here. Then, this one is that it is continuous and there's no gaps. See, it is continuous, there's no gap. Yeah. Then it is symmetric about the mean. Now look at this. Half of this, you can literally fold this into that. So just like our body, halfway the same as to the other side. So it is said that it is symmetric about the mean. Then the next one is that the curve never touches the x-axis. So you can see this is the x-axis right here. It keeps getting close but never touches it. So the total area is 100%. That means that's the one I did first. 0.5 plus 0.5, which is 1.0 or 100%. Okay. So these are the properties. Now we can see how to find the area under the normal curve. We'll just do just the area under, how to find the area under the normal curve. So to do that, after this section, I will stop so that I don't confuse you. Okay. That is one. It says here, to be able to do that, you need to know I have the table. There's a table we call normal distribution table. So I'm going to upload that table for you here. Normal distribution table. I'm gonna put it here. See if I can find this. So it's called statistical table. Statistical table right here. This right here. I'll upload it. Oh, they have it already in. It. So now I'm gonna put it on the models. So that when we see on Monday, we can use it. I will explain more how to use it. I'll be putting it on this section, normal distribution. See. So I'm gonna file statistical tables. Oh, right here. That'll be right here. Statistical table. That'll be somewhere.
Is it labeled statistical table? Because if so, I seen one back at first where you was at.
Yeah, I mean, let me see. That what it should be. Statistical table. See one before? Okay. Yeah, it should be labeled statistical table. Yep, it's gonna be. Yep, right here. Adam. So it's here now. It's gonna be here. So I have not published this model. So I'm going to, since I'm going to put it here as well, so that you can use, because this one's for next week. So I have to update it before I can publish it. So I'm gonna put the table here. Oh, right here. I have it here too. Mr. Joe, you're correct. It's here as well. So you can, this way you can download it. I'm gonna close the Excel so we can have more room. Yeah. Okay. Let's open it from here. Okay. This is the table I'm looking at. Table we'll be using table 6. So I recommend that you print this table. From now on, we'll be using this table. Print it and keep it handy.
The one you just uploaded that says July 2017?
Yeah, this one here. This one, let me see. Close this. Okay, let's see if I can see this one now. It would be like 7 pages. This one, download it and print it. From now on, you'll be using it. Then next one, another thing I would like you to print will be this one here, and keep it handy. It is called procedure table. Yeah, it's gonna be procedure table right here. Procedure chart, really, not table. It's a chart. So I'm going to upload it there as well. So I'm gonna close this one. Okay. Then I'm gonna put it on this place. That's a file. Upload procedure. Chat, procedure table, chat. Oh, I have it there already. So I have it on the modules already. Just to find where it is located. So I will put it here. Procedure chart. Looking for it. I'm gonna find where I put it. Gonna be somewhere up here. Procedure chart right here. So I have both of them here now for you. See, the 2 of them. You can download the 2 of them from here. They are here. The statistical table and the procedure chart. Now, let's try both of them. I got procedure chart and the statistical table. We'll be using start from table 5. So you can see table 5 right here. Okay, and you can see the other one with the chart here. Okay. Now let's do one example so you can see where I say that we'll be using this from now on. It says here, find the area under the normal curve which lies to the left of Z 1.76. Okay, let's start with part A. It says to the left of Z 1.76. So the left of Z equals 1.76. So what do we call it Z? Because when you look at the table here, we look at the table, we look at the table. This is the table right here. You can see that Z is the standard Z. It said the table represents the area under the standard normal curve from 0 to the specified value of Z. You can see the Z right here. All these are the Z's. Yeah. So this time around it says Z 1.76. It says to find the area under that. First thing you do is to draw the chart. So I'm going to draw the chart for this. Okay. Tab 0. Then 1.76 might be somewhere here. Sure. Okay. Then you start to draw. Okay. I'll make a drawing. Then put the curve. No, you guys will be using pencil, so I'm a pen to draw it, so it will be more easier for you. Okay. Center line. Put the center line to the mean right here. Then it says this one represents 1.76. And it says here, according to the equation, it says to the left of 1.76. This is 1.76 here. 1.76 right here. See, this is the left side of it. So that means you're gonna share the left side. Okay.
So that means it's gonna be a negative, right?
No, it won't. Remember that I said that the probability of an event can never
Be negative.
ever be negative.
Right.
So shared. So this area that I shared, these are the area or the probability that we're looking for. The one that I shaded, because it says to the left of that, to the left of this number. So it's to the left of it. Okay. Now, so it says find the area. That means like saying find the probability to the left of that. So the area will be equals. Now, see, you can see look at this shape, how it looks like, right? Now you go to the procedure chart, that chart that I mentioned. The chart, procedure chart, what is it? Okay, let's see. Procedure chart is right here. So you look at the chart let me make it bigger. What chart here looks like the one I have on the paper?
The bottom left.
Bottom left, right? Yeah, this one, right? That's this one, right?
Yes.
So what does it say?
Yeah, I agree.
It says to the left of any Z value, where Z is greater than me. Say, look up the Z value to find the area, then add 0.5. Look up the Z value add 0.5. So
Area.
now our Z value, say look it up and add 0.5. So that means our Z value is right here is
1.7, right?
1.76, right?
Mm-hmm.
So we look it up and add
Can
0.5.
you go back to the Z values real quick, please?
The Z value, okay,
So 1.7, that'll be what?
1.76 right here.
0.4554?
Mr. Joe, you see it?
Yeah, I said I ain't understand. I just looked at the graph with
Yeah,
the
graph, you see,
numbers on there to see how to find it, but I understand it now.
okay, good. Then let's find 1.76. You go over and look for 1.76. This is Z. 1.7 is right here. You can see right here.
Right.
Then you gotta go under 6. This
Under
is 6
6.
right here. So you follow it under 6.
So 0.4608.
Exactly, 0.4608. 0.4608.
And then you would add 0.5.
0.5. Yeah, yes,
Okay.
0.4608. Lost. We got an Einstein here.
I'm crying.
So you call it, you can add this, you're gonna get, you can verify this with your calculator. 0.4608 plus 0.5, that gives us 0.96, right? 08,
Hold on, doing the math.
right?
Hold on, doing the math.
Come on, Mr. Channel. You're always looking for, you're
0.9608.
always looking for attention, don't you?
Huh?
You're always looking for attention, don't you?
No. 0.9608. That's right.
Yep, correct. You and the other lady in the class, 2 of you.
Don't talk about us.
So this is it, how to use it. You draw the chart first. Some chart might not look like this one. Like this other chart will not look like this one. But once you draw the chart, the graph, then what you do is you go to the procedure chart to see which of them that looks like their chart. Then follow the direction from there and answer the question. So we will discuss this more when we meet in class. But I want you to get, to get you started on it, so you can know, you can have an idea what the kind of stuff we'll be doing under normal distribution. And maybe we can, let's draw the second one, right? Let's do it. You ready?
Right, come on.
Right or wrong?
I guess
on.
we're ready.
Right. We guess, Chanel.
Okay. Okay, look at this one. Say to the left. This time, say to the right this time. To the right of Z 1.76. So what you're gonna do is, again, draw the chart 0, 1.76. Then you make your diagram. This time is set to the right. So I'm gonna draw it. Okay. Yeah, all right. Then can hold this. All right. All right. Okay, I'm good. I think I'm good. I'll bring it back. All right, so we'll make some adjustments here. Then bring this here. Now let's make the plot. Put a center line. Then put the line for 1.76. Now the one we did before is set to the left of it. The left. This one is set to the right of it. So we're gonna share the right side. Yeah. Yeah, I have. Okay. Yeah, I'm showing the right side of it. Right, so this is how it looks like. So our area now, we can find our area here, which is the same as saying probability. So to the right, so now let's go and look for the chart that looks exactly like this one. look at our chart. Which of them look like what we have here? Which of these charts looks like
Go
that?
back to the
Right,
chart.
is it the second one?
Yeah, this one, right? You mean this one, right?
Yeah,
Yes, exactly. That's what it is. So
okay, so now we subtracting the 0.5.
yes, exactly. It says look at the z value, then subtract 0.5.
Okay,
That. So we have the z value already. So 0.5 minus, because we have it from the table already, from the other
Right.
assignment, right? We have it as 0.4608.
right.
Mhm.
0.4608. So I'm gonna write it down so I can get it from the calculator. 0.5.
It's 0.0392.
Yeah, trust but verify, right? Miss Chanera, right?
Verified.
Trust but verify. So I trust you, but I gotta verify it though.
Okay.
Is your feelings hot?
Yeah,
Come on, Miss Chanera.
my feelings are hurt.
You know I gotta do. I gotta do this.
Don't forget the decimal.
Yeah. Minus 0.46. 0.0392.
Yeah,
0.0392. Let me write it down. Is that what you said before?
that's what I said.
I wish I could bet on that. I should have bet on it. Take
That's what I
bet on
said.
it. 0.0392.
Mm-hmm.
Or if you like, you can call it 3.92%.
Mm-hmm.
Oh, excuse me. So, and then any question on this before we do the last one? This one.
No, I
Anything-
think I
No.
just started to understand it.
You understand it?
Yes, now
Oh,
by
oh,
the time we got to the second one, I think I got it.
oh, that's cool. That's cool. All right, let's do the last one then before we leave. Say between the two, say between these two numbers. It says part C says between Z negative 0.87 and Z 1.28. So again, we draw this chart. We got on this side we have negative 0.87, 0, 1.28. So let's draw this chart right here.
Okay, so now it's on both sides.
Yes, on both sides. So we have, yeah, I'm gonna make a lot of adjustments here. Okay, it's on both sides. Okay, bring this closer. All right, now I'm gonna make these adjustments. I'm gonna put the center line. Center line is here. Then for the negative 0.87. Okay, that will have this line here. That. As a matter of fact, you're gonna go excuse me. What did I do? Yeah. Okay, that's what you're gonna be. Now for this one, 1.28. The line will look like this from the same side, but just a minor. Okay, good. And it said between them, between these two numbers. So you gotta share between the two of them. Okay. Let's show. Yeah, sharing it. You know, if you're doing it on paper, it's very easy. You just draw the line or use a pencil to share it. But on computer, it takes a while, you know.
KK, cut it down some.
Huh?
Sorry, I'm talking to my son.
right? This is the last shed. See, now we have shaded it, and it says this is between negative 0.87 and 1.28. Now, next thing is to go to the procedure chart. Which of this chart looks like what I have on that
Number
page?
4.
Yep, exactly, number 4. And it says look up the Z value to get the areas, add the areas. So this time we're adding it.
We adding 5 to each one.
No. You didn't say that. Come on, Shanela. Don't put us don't confuse us now. You just say look up the Z value to get the area, then add the areas. It
How do we look up?
it
What
doesn't
we
mention
looking
no
up?
5 here.
Oh.
Yeah. So now let's look it up. Negative 0.87. Now I want to show you, explain something here. This negative sign here means that it's on the left side. That's all. So that means you're not going to be looking for negative 0.87. You'll be looking for 0.87. Now I want to say this. Use this table that I show you. I say print it out. Use it. There's another type of table, the one you have in your homework. That one have the table for negative part of it. I mean, if you know how to use it, you can use that. You should get the same answer correctly. But if you're using that one, don't use this chart, the rule on this chart. This chart applies only for this table that I say to print. So I recommend you stick to this table. You still get the answer correct. So, but if you prefer to use the one in your homework, then don't use this chart for it.
Okay, so
You have to follow the direction, the way they explain it on that table.
So you said it's not a negative, it just means it's to the left side, right?
Yes.
Okay.
So that means we go to the this is for negative 0.87, negative 0.87 equals. So we go to that the table for that. This one here, 0.87. So look for 0.8. This is 0.8 right here.
You moving it, yeah.
This is
That's
7 right here.
0.3078.
0.3078. Yeah, correct. Because this is under 7, and this is 0.87. Yeah, 0.3078. I'm gonna write it down. 0.3078. Now the other number we're looking for is
1.7. I mean
1.28.
1.28.
Yeah, 1.28 equal we go here, go to 1.2 under 8. 1.2. The 1.28.
It's 0.3997.
1.28. Yep. 0.3.
997.
Yeah. 0.3997. Correct. 0.3.
All right, so you adding both of them together.
So that means
Okay,
the area we are looking for now becomes area equals 0.3078 plus 0.3997. So let's go and put this on the calculator.
It's 0.7075.
Good. Very, very good. But you know I gotta verify, right? Do I place a bet on this one? I should place a bet on this one, see if you're right this time.
Go ahead, put a bet on it.
All right, my bad. 3997. 0.70.
Yep.
0.7. Is that what you said? Are you sure you said this?
0.7075. Yeah,
I'm hearing it now from you.
that's what I said. Oh, that was easy.
Yeah.
Put
0.7,
it
right?
down, okay?
Huh?
My bad, I'm talking to my son.
Okay. So that means this is where we stop. Next week we start from this one. This one is basically the same thing, except that here they call it area.
Okay.
They call it area, but here they call it probability.
Okay.
So that's why you have this P of this, P of that. The same process. So we can try, we'll meet on Monday. We'll try some of this. Then now we now go to applications of that.
All right.
I know you want this one, me upload this one too, right? Okay.
Yep, you know it.
Okay, let me save it so I can upload it there as well. All right.
Also,
Yes.
Professor, I have
Yes,
a
ma'am.
question.
Huh?
What's up with the what we opening? So
Oh
we can
yeah.
read.
Please remind me on Monday. I said
All right.
Monday, right?
All right, that's fine.
So that we'll be in class, I'll be facing so we can do it together. And here is
All
is on
right.
What are we talking about here?
huh?
We talking about the stuff he
The
gonna reopen.
assignments that he
Yeah,
said he was
the second
gonna
chance,
open
yeah.
up the second week in July.
Yes, that's what
All
was
right,
just
bet.
asked. So on Monday, let's do it on Monday. So I will be in the class and it's challenging to do it on remotely like this.
Okay.
Okay.
Mm.
Sound like a plan.
Enjoy your week.
You
All
too.
right, see you. See
Enjoy
y'all.
your weekend.
All right.
You too. Thank you.
Don't go to club now, okay?
Can we get back in the group chat? Because I don't know what happened last night. I went to sleep.
What
Joe,
happened?
you left the building.
What was that?
Joe left the building.
What
Sorry.
did Joe say? Joe say something.
I went back in the group chat. I fell asleep.
Yeah, we all fell asleep. I think me and
The class
my-
just started a group chat, Professor.
You guys have it. Oh, my bad. Okay, you guys have fun.
All right.
All right.
Well.
Thank you, Dr. Roger. Have a good day.
You
So,
too.
Professor, you said we'll do it on Monday.
I'm going to put the video, this video on in the announcement section, so you can watch it if you want.
Oh, good.
Yeah. Somebody's raising their hands. Who is raising their hand?
My bad. I ain't mean it.
Okay. All right, guys. I leave you in peace.